Yeah, thanks for the great introduction. I'll actually talk about that exact example in my talk. Hi, everyone. My name is Yoonho Lee. I'm from Stanford University, and I'll be talking about Clarify. I primarily publish in machine learning venues, but today I'm here to try to convince at least some of you that this is like a problem worth working on, because I feel like this core issue that a lot of machine learning people are working on, which is aligning models to human intent, is, in my view, at its core, an HCI problem. So hopefully I can convince some of you of that. So, your example. So machine learning models, they often rely on the wrong features. And this happens because machine learning, we're fundamentally, all the model's doing is it's extracting correlations out of the data you give it and exploiting that. So when the data has wrong correlations, it relies on the wrong things. So here, let's say this is our training data, and we tell the model that this image is a husky, this is a wolf, this is a husky, and this is a wolf. And we show it this image. A model trained on this sort of data will likely say that this is a husky because the background is white in most of the husky images, and this one too. So it learns to focus on the background instead of the animal. And this is all downstream of the data generating process having unwanted correlations that don't really correspond to what we want the model to do. And this problem it's a real problem. It's not like a made up wolf thing. This causes real harm. So there was this example where Amazon tried building an AI recruiting engine. So this would be a computer that you give all the details of a candidate, and it would tell Amazon whether or not to hire this person. And it turns out the training data that went into this was pretty heavily skewed towards male candidates. So even if you had the same qualifications, this system would prefer a male candidate, which is obviously unfair. As another example, there was this compass system for criminal justice. And similarly here, the training data was skewed towards favoring white defendants. So given the same crime, the system would be a lot more lenient towards white defendants. And this is, so these types of problems where models rely on spurious correlations, they happen all the time, and they can cause real harm if we try to naively deploy models like this. So we would like to solve this issue. So the traditional approach, most ways of solving this problem kind of reduce to this, where you just gather more data that resolves the bad correlation. So if you had data like this, a machine learning expert would look at the data, they would look at the evaluations, and decide that we should go out, take more pictures of huskies in grass and wolves in snow. And this does solve the problem, but it's very costly. So if you imagine a real scenario where the data on the left is millions of images, to balance out the populations, you would need something on the order of tens of thousands or something to add to that data set. And this would be from a population that it was initially hard to get data from. So you might end up introducing additional correlations. So this it's costly, it's sometimes impossible, this strategy. And in this work, we take a very simple approach. Our core idea is we know what the model's doing wrong. So we built an interface where users can just look at the model's behavior and directly tell it what not to focus on. And we have plenty of reason to believe that something like this should work, because the foundation models that we're building on, they know a lot of concepts. So if you just take the image on the right, ask a model, do you think it'll be cold in this region? Is there snow? How many trees are there? They can answer these questions with reasonable accuracy. So these models know the concepts. The training data was just insufficient in communicating what we intended. And with a little bit more information, we could get these models to do what we want. So we propose Clarify, which is short for Corrective Language Annotations for Robust Inference, where in addition to standard supervised learning, we allow users to give language feedback to models, and we propose a way to directly incorporate that language feedback to improve the model in a completely automated fashion. Here is the whole workflow that we use. We gather initial data, we train a model, and then we visualize for one class the model's errors. So from a validation set, we take all the examples that the model got right on the left and all the examples that it got wrong on the right. And by juxtaposing these two populations, we would, hopefully a user that sees this could be able to tell you what the model is consistently mistaking. And then we ask a user for a verbal description of how these populations differ. And I'll briefly go out and show you a demo. Yeah, so this is the screen that our interface shows a user. We see correct examples on the left, incorrect examples on the right, and these are all images of squares. And as you can notice, the model is consistently wrong on red squares. So the user might look at some images and write red in the text box. And when they do that, we show them immediately the images that are more similar to red and less similar. So we provide immediate feedback on whether the model understood the phrase that the user used. And the user can look at this again and try to come up with more phrases, and finally they submit a final text phrase. So having collected verbal text feedback, we then use this. We use the exact data that was initially used to train the model, but we reweight it. So how this works in this example would be, because we know that the model's wrong on red squares, we know that in the training data there was insufficient representation of red squares. So we take all the examples that are more similar to the phrase red, and we upweight those. And because now the model would see, after we retrain it, it would have seen that red things can be squares too, and would rely on the shape rather than the color. So that was our workflow, and we did a user study through Prolific to answer whether non-experts could use this interface. We had minimal qualifications, and we evaluate on 2 data sets that are commonly used in this literature. They have a known spurious correlation. So the first task is a bird classification task, where the species of the bird is correlated with the background, because they live in specific places. And the other is a hair color classification data set, where hair color happens to be correlated with gender. On these 2 data sets, we show the results here. Each bar is a different non-expert user that we got through Prolific. And the score is a measure of how well the user's provided phrase separates the correct from the incorrect examples. And the black line there is my reference prompt, given my knowledge of what these data sets include. And you can see that a lot of them got slightly lower scores than me, but they were at the correct concept. So maybe I said forest and someone else said trees. So if they were to rephrase a little bit, they would have gotten a similar score. And surprisingly, some people got a better score than my reference prompt and came up with some correlations that I didn't really know of. Yeah, so aside from the 4 in each data set where they failed to kind of understand the task, we were able to take their phrase and retrain the model and have substantial gains in underrepresented population accuracy. And this whole thing was fairly fast. So each interaction with the data set took a median of less than 3 minutes. Yeah. So yeah, that was our paper. I'd like to talk a little bit about high-level advantages and limitations of this work. Because our verbal feedback is based on an initial trained model, we get to, instead of trying to state upfront everything that the model should focus on, we can wait for the model to use its inductive biases and only target its failures, which is very efficient because we don't have to say everything. And another point is that we're working with global feedback instead of data point level labels. And this makes supervision very cheap because, as I've shown you, we're able to handle data sets in the order of a few minutes. And with data point labels, you would have needed on the order of 1,000 labels. Yeah, in its current form, the limitation is that we're identifying and correcting only one kind of model failure so far, but I think this can be expanded a lot further. In conclusion, we introduced Clarify. We show that users can just directly tell the model what it's doing wrong. And yeah, we instantiate this in a proof of concept system. From a zoomed out view, I think we should really focus efforts on building ways to communicate to machine learning models at a higher level of abstraction because they're ready to receive that. Like the foundation model includes enough knowledge too. There's a lot more details in our paper. The interface code is online, and I'm happy to take questions. Thank you.
Hi, Eldon Shoup, Apple Research. This is really cool work. I had a question about I guess the annotation task, which is, there are obviously many cases in the real world where the kind of unwanted correlations that you have in a data set aren't immediately apparent, right? Where, like Celeb is kind of like a nice artificial case because that data set is known to have a lot of issues. And I was wondering how you imagine kind of reckoning with those problems, right? Because it's very difficult to kind of inductively forecast unwanted biases, especially, for example, if you have a model that hasn't yet hit production. So are there ways that you're thinking of that are kind of on the roadmap to begin addressing some of those issues? Or what are your thoughts when the correlations are not immediately visually apparent?
Right, that's a good question. Yeah, of course, correlations can be a lot more subtle than we can see here. I think even in those cases, we can, for example, if we were to pick the right subpopulations and show them to a human, they'd be able to verify that this is a conceptual error in the model's part. So I think some form of automated processing upfront would be able to make this ergonomic enough for humans to tell you that this is a true error.
Cool. All right. Thank you.
Thanks.
Hello, this is Wesley from CME HCI, and welcome to your first HCI conference. And also, I want to say, you don't need to convince us that we need interface and everything. You have to convince AI people that this is important. So present this in an AI conference again. My question is actually very simple. So who are you envisioning? We're saying users, right? Who are you envisioning these users are? Because my question is, when you are using, they're encountering images or AI in their daily life, they don't necessarily look at the data set you're presenting them, right? And the second thing is they might not just verbally say why the model is doing wrong. So are you envisioning this is a tool for maybe a crowdsourcing pipeline where getting information from users, or you're thinking about it's more of an in situ features incorporated into a AI system where you let end users do this, or it's more professional evaluators or auditors? Yeah.
Right. Good question. Honestly, I guess my answer is kind of all of the above, where this could be within casual interactions with a daily, a model that you use daily, and you could slowly tell your preferences to it so that it personalizes to you. I also think that the main thing we demonstrated is the potential of this as a crowdsourcing application. I also think that probably experts will be like even better with this. And you can imagine getting doctors to interact with medical AI systems. And any like high-level errors there, doctors would be very good at identifying and verbally describing. So I think, yeah, on all those fronts, there's potential.
Great, thank you so much.
All right, why don't we have our next speaker set up? So just as a transition, did you know that 73.2% of ML practitioners want to be able to specify corrections to their model at the concept level and not at the data level? How would you verify that? Well, our next speaker. Our next speaker